Now here we see the formulation step of LPP, and here are the details of the formulation. Firstly, we assume the appropriate decision variables, and as we have seen, we have assumed them as x and y. Okay, we should remember what does x mean and what does y mean. So in this particular case, x means the number of bicycles that we are intending to manufacture, and y means the number of tricycles. Then we have to find the expression for the objective function. That means we know that z is a profit, and we are given what is a profit for one bicycle as well as one tricycle. We know that the profit given was 900 rupees for one bicycle. So therefore for x bicycles it will be 900x, plus for one tricycle the profit is 1100. So therefore for y tricycles it will be 1100 times y, and hence addition of the two will give us the total profit. So this is our objective. This is what we have to maximize. Then we have to find all constraints. If you see, there are constraints given in terms of the time availability of machines A and B. So those are the stated constraints. So time availability on machines A and B. If you see, there is one more constraint which is not given, but we have to identify that, and which is a very obvious constraint, and that constraint is on the number of bicycles and tricycles. Although we have x and y to be variables, but they cannot take any values. You see, since they represent the physical objects, the count of physical objects, they must be non-negative. Okay, so this is where we have a very important type of constraint which is never mentioned as such, because we have to identify it on our own. That is called as non-negativity constraints. So x and y cannot be negative because they represent the number of physical objects. So that is a non-negativity constraint. So that means we have basically x always greater than or equal to 0, and y also we want to be always greater than or equal to 0. And having done everything, finally we write the formulated LPP in this particular format. Okay, we start by saying either maximize or minimize based on what has been asked. Then we write the expression for the objective function, that is z. Then we say subject to constraints, and then we list down all the constraints that are applicable to the problem. Okay, so now let us go ahead and see the details. Now here we have summarized the entire information given in the problem so that we understand the whole problem properly in the correct perspective. See, there are two columns for representing bicycles and tricycles, and in the rows we are mentioning the time required for one bicycle and tricycle on each machine respectively, A and B. So based on the data given, we have written all the the details. Then the last column is about the maximum availability of machines. So for machine A, it is given that it's available only for max 120 hours, and for machine B it is 180 hours. Then we have been also given what is the profit that is made by selling one bicycle, that is 900, and profit per tricycle is 1100. Right? So therefore the final LPP will have to be made now. For that, we have already assumed the decision variables, that is x and y. The next step was to identify the objective function, and this also we have written that the objective function is z, nothing but 900x plus 1100y. So the second step is done. Next is we have to write the constraints. Now this is a very important step. If you see, the constraint is there on availability of machine A. So we have to find out how much time we are proposing to use on machine A. If you see, one bicycle needs 6 hours and we are trying to manufacture X bicycles, that means the total time taken by X bicycles on machine A will be nothing but 6x. Similarly, total time taken by Y tricycles on machine A will be 4y. So hence the total time for which machine A is occupied because of X bicycles and Y tricycles is 6x plus 4y. And this total time has to be within the maximum available limit. So that means whatever expression we get, that has to have value less than or equal to 120, because it is a maximum availability of time. And similarly we can write for machine B also now, since we know how to do that. For machine B it will be 3x, because x bicycles would need 3x hours, plus 10y, because y tricycles would need 10y hours, and here also that has to be within the limit of 180. Correct? So these are, we can call it as time constraints. Then we have also non-negativity constraints, as we just saw. That is, the number of x and y itself cannot be negative, so therefore x and y both are supposed to be greater than or equal to 0. Okay, and therefore now finally we go ahead and write the formulated LPP. So that's given on the next slide. So this is where the precise mathematical definition of the problem. So we say that we have to maximize z given by 900x plus 1100y subject to constraints 6x plus 4y less than or equal to 120. This is a constraint for machine A. Then 3x plus 10y has to be less than or equal to 180. That is constraint on machine B. And x and y both must be greater than or equal to 0. So that is the non-negativity constraint. Right? So this is where the formulation ends. So we have done the first major step of LPP, and now we proceed to the solution phase of the LPP.